Continuing our SN1, SN2 discussion. It looks like the same question over and over, but there's subtle changes going on here. I think we can steal our first part of the analysis from our previous activity. Rx is secondary, Mabata SN1, SN2, correct? Same starting material. And we're using the same color scheme. Rx in green, blue, red. Okay. Green, blue, red. Rx. Secondary. SN1, 2, question mark. That's about as short as you can get it. Blue, new. RSH, neutral sulfur is the category. Don't give me strong, not for neutral anything. Don't give me poor, that has to be neutral oxygen. What's in the middle? Moderate. Hey, are you leaning strongly one way or the other if you're a moderate? You got the same conclusion. Mabata times 2. 3, solvent. Phenyl CH3, toluene is non-polar. I need a category, and I like your conclusion. I got 2 things saying I don't know, and I got SN2. Where are you going? That's your only thing to go with, SN2? No. You've got one thing leaning you away from I don't know, and you gotta start leaning that way yourself. And the same product as before, I'm pretty sure, and my strategy was to copy and put the new nucleophile on the end. Now, you're going to say, wait, where's the hydrogen on the sulfur? Good question. Hold that thought. That was a great question. Where's the hydrogen that used to be on the sulfur? And the answer is, you get this. And there's no telephone pole there. So don't tell me this is a transition state. What does a square box without the telephone pole mean? Intermediate. And this, all I have to say is the pKa is less than 0. And how do you know that? So, that's not on my pKa table. I didn't know that. You have a whole category with oxygen with a plus charge on your pKa table, and they're all negative, hydroniums and oxoniums in general. Periodic table says if you go down a column, the acids get stronger because of size. So sulfur with a plus is even more acidic than oxygen with a plus. So yes, these are all strong acids. Never put a strong acid in these boxes. Never finish with a strong acid. The solvent grabs the H, but the solvent really can't, or the nucleophile. There's always something to grab an H from a strong acid. It usually ends up in the solvent. And there you go. Your old R stereo center is now S. Why is it S? Because you chose SN2, right? Now we have the same conclusion for nucleophile. RSH, moderate. SN1 or 2, don't know. Solvent's different. ROH. Oh, any hydrogen bonding solvent is which category? Polar product. Careful, there's polar's involved in 2 names with different conclusions, so you be careful. Polar's not the whole deal, right? There's polar aprotic. That means it's got a polar bond, but it's not the H. There's 4 of them: acetone, DMSO, acetonitrile, and dimethylformamide. They're on that table, page whatever in the book. Also previous on this activities. Yeah. What's your conclusion for polar product? Those are carbocation sisters. SN1, the one with the carbocation. So finally, you're going to say SN1, right? And you're going to show me you know what happens to a stereocenter in the SN1. Here's what you're going to do. Oh, you can use that word. That's a dangerous word. It's a nice word, but it's dangerous too. Here, she said, I have no problem with what she said. She said, you can say this has to be racemic. You could write that down. Racemic. This is the safer way. Tell me you know that stereocenter is 50% R, 50% S as quickly as you could. So 50% R/S does it for me. The only reason I don't want to write the word racemic here is if there's another stereocenter in my molecule and it didn't change during this reaction, then you would have two products and say the original stereocenter that didn't change was S. So you'd have two products, S and the new stereocenter also S, or S and the new stereocenter R, and they are not enantiomers. They're diastereomers. So I don't want you memorizing when do I use the word racemic and when do I use the word diastereomers. This covers it. Write it this way, and you never have to say anything else. You're acknowledging you know what happens to a stereocenter during an SN1 reaction by doing it this way, right here. 50% R, 50% S. You did not show me one stereocenter. You said it's two. Okay, and that's a good activity.